But yes, hi, I'm Felipe Hoffa. I'm a developer advocate for Snowflake. Last week, Vino, who got accepted this talk here, told me that she's traveling this week, so if I could take over this talk. And so now I'm the one delivering this talk. I'm super happy to do it. As a developer advocate for Snowflake, I love showing what we can do with Snowflake. And as it says, the promise for this talk is one, the demo of recording audio and getting to show ads. I'm sure everyone has noticed that when you talk with friends about something, suddenly 4 hours later, five hours later, you get an ad for that thing. So one of the Snowflake engineers was wondering how to build that. And we're going to build that with what Snowflake provides, which is streaming and dynamic tables. And because we're data people, I'm going to focus a lot on that side. How do we do this with Snowflake? But I also have to show you the demo. Somehow, I didn't get the microphone to work on my laptop, so we're going to see the demo from we're going to get the big picture, but I'm also going to show you the code so you can reproduce it at home with a laptop that can record audio. Also, I see how giving this talk here is a little bit ironic because this is the Real-Time Analytics Summit, and the keynote was all about how do we do things in less than a second. And what I'm going to present you today takes more than a second, sometimes several seconds or sometimes a minute. And that's what I have. So it's good to be able to, one, give results in milliseconds, but it's also good to think if we had more than a second, what would we be able to do with more time? And this is my favorite thing lately. I also host live streams for Snowflake on LinkedIn. And these were my real-time results of how many live viewers I had. So I love when we do analytics. I love what we do, use the latest technology. And somehow, here I was having a negative number of live viewers, which I still don't understand if it was zombies or if there were more people leaving the room than connected. I have no idea how it got this bad, but this is just a little observation on what happens sometimes when we have to do things in real time, and then we might need more time to get the correct results. It's all good. It's all a continuum. So yeah, this is my talk, streaming analytics and dynamic tables. And I want to start by delivering what I have from the demo. And luckily, we have given this demo before. This demo was written by Tyler Jones, presented last year at Summit. And what we want to see here, this is a Python UI that's showing what the computer is doing. The computer is listening to everything that we're saying. I'm going to show you the code. It's using a model to transcribe to English, and then it's sending the words via streaming to Snowflake. And as it's getting words, it starts showing ads depending on what words we configure to trigger an ad. And we can play the video now. We can watch it working. I also did this in a live stream with Tyler Akidao. Tyler is a legend on the streaming world. He's been behind Apache Beam and a lot of what Google did. And Tyler is also part of the big team that created dynamic tables and streaming at Snowflake. So we can watch those videos, but I'm really interested, because we are data people, on showing you how the code is delivered in this demo. It's all on GitHub if you want to play with this at home. It has 3 parts. We have the Python app that's delivering the whole UI and listening and transcribing. We have Java code. That's the one streaming into Snowflake. You can stream to Snowflake using either Kafka, what most people use, but we also have a Java SDK That's what we are demoing here. And now more people are building with these blocks. For example, Kinesis can stream directly to Snowflake. Then this is the Python code. So let me go deep into what the demo is. So you can see here that we are using PyAudio to record from the microphone, and we are using Whisper to do the transcribing. These are the constraints, etc. Oh, the third part that I didn't mention, I mentioned three: Python, Java for streaming, and then on the Snowflake side, we did everything with SQL, and I will go deeper into this in a second. But basically, Python is connecting to Snowflake, creating a table of common words. We don't want to show ads for common words. Where these are the keywords we want to show ads for. If someone says Vegas, we want to show ads about Vegas. Streaming, we want to tell people to try Snowpipe streaming. This is an old demo, so if anyone said Swift, Tyler was asking for if anyone had tickets to go watch Taylor Swift, not Tyler Swift. And then we created a dynamic table that I'm going to explain in a second what a dynamic table is in Snowflake, where that's doing the word count. We also have a dynamic table that gets all of the ads. This is the audio part, how we are recording audio and getting it to transcribe. Again, you can repeat this at home, all done in a real-time thread. We are monitoring that thread, and we are looking at Snowflake. Because we are processing all of these words and ads in Snowflake, we're looking if Snowflake has produced any new rows in a stream. And that's how we split the words and how everything is running. Then, on the Java side, how are we streaming? Basically, this little app is looking at the standard output from the Python job. The Python job is outputting the words that it sees. The Java app looks at the standard input, takes these words, and streams it directly to Snowflake. And it's basically streaming word by word. And then we are connecting all of these together. In terms of latency, when you stream to Snowflake, Snowflake will see these new rows in 1 second, 2 seconds, 4 seconds, which might sound a little slow, but it's part of the continuum of how we do streaming analytics. Sometimes we want things very, very quickly. Sometimes we're willing to wait a little more. It's all about cost, precision, and what results we want. Also, we have a small audience, so if at any time you have more questions or you want to go deeper into any topic, please tell me. I'm here to give you the best that I can. So yeah, that was the demo overview. Sorry for not speaking directly to the laptop, but hopefully you understand that at least we were able to see the code. We're talking about why streaming. We are at a streaming conference, real-time conference, so you understand that part. What Snowflake has to offer here, we're going to talk about dynamic tables, look at some reference architectures, and what's the latest. Yes, this conference is all about getting things to run in less than a second. Now, when Snowflake gives this talk, what we like telling you is that streaming is, there are many choices when we are streaming. It's not all about getting the sub-second results. Sometimes we're OK with waiting 1 second. Sometimes we're OK with waiting a couple minutes. Sometimes we're OK with waiting hours. We need to figure out where is the value for our business and the cost of delivering sub-second latency for a thing that would have been the same if we had delivered it 5 minutes later. And if we have 5 minutes, we can do so much more. So let's connect everything together. In fact, StarTree has a Snowflake connector, so we can make everything work together. So yeah, sub-second, high cost, low return or high return, depending on what we're doing. And the question is, can we manage the cost and manage the latency in a simple way? What Snowflake wants to provide here is like, yes, I can give you things in less than a minute, or I will let you dial if you wanted them in 1 hour, and you will see the cost go down, which is pretty cool when you can do that in a simple way. So streaming in Snowflake, streaming before, it can be complex, it can be inefficient, it can be hard to manage. What we try to do with Snowflake, and you can try it out, simplified pipelines, having support to stream rows into Snowflake, and having support to read files and connect everything together. It's pretty cool when it's simple. In fact, now streaming rows to Snowflake is way cheaper than streaming micro batches, depending on what type of data you have. And having everything in the data cloud, having everything in a consistent place, sending everything to a well-governed place, that's Snowflake, that's pretty cool. This would be a pipeline. As I was telling you, we can get Kafka, stream from Kafka, we can stream rows. And also, if you have an S3 bucket and you want to put files there, Snowflake, you can configure it to ingest those files as quickly as possible. Snowpipe gets to interact with all these kind of inputs, and then we have things that we put in tables. We have traditional analytical tables. We are going to launch soon in GA. It's public preview now. Hybrid tables, if you want to do more of a transactional workload. We have the dynamic tables. That's what I'm going to go deeper in my next slide and how they work. What's cool about Snowflake is it goes beyond SQL. You can work with Java. You can work with Scala. You can run Python inside Snowflake. And now we also have the ability to run containers. So in this demo, we were using Whisper within the Python client. We could also send binaries to Snowflake and have Whisper do the transcription inside Snowflake. That's not part of the demo, but things that we can do. And then we can deliver that data and share it with any process that needs it. Snowpipe, files and streaming. You send files, Snowpipe eats them, streaming, rowsets, and Kafka topics. And those are the basic two connectors. So what we have here is that Snowpipe will do the duplication of files. It will auto-scale the resources. If you want to ingest 10 terabytes per hour, no problem. And then Snowpipe streaming focuses on rows with lower latency and lower cost. And there are channels so to get the ordered ingestion. And going deeper into Snowpipe streaming, you can just, I told you, via Java SDK, no files to stage. It does exactly once, and per channel ordering, low latency, high throughput, gigabytes per second, not terabytes. The configuration is really minimal. We can go back to the Java code when we were setting up the channel to stream to, low cost. And it streams, it connects with the major players in this area. And this is the latest Snowflake innovation, dynamic tables. They look like SQL tables. They look like materialized tables. But one cool thing that they have is that you just create it as a select from somewhere else. You can do joins. You can use UDFs. You can use Python UDFs. And as the source tables that these dynamic tables look in get updated, this table will get incrementally updated too. With what frequency? That's the part that I love, is being able to set up a target lag. Do you want this data up to the minute? Do you want this data refreshed every hour? The dynamic table is able to You can dial this up and down depending on how much you want to pay. And the refreshes will not run if none of the sources have refreshed. Like if I have the target lag 1 hour, Snowflake will look if any of the sources have new data. If there's no new data in those tables, if nothing has been deleted, inserted, updated, then we don't need to run it. If there's something new, then we will have an incremental update, if it's possible to do an incremental update. And the other cool feature here is that you can connect a lot of dynamic tables together. So instead of setting a target lag for every table, you can have a whole tree. And then you can say that the lag depends on what everyone else wants. So everything can have a lag depending on the other tables. And then on the last one, you say, I want this to refresh every minute. The whole process will refresh every minute. Every hour, boom, suddenly you are paying way less, and you're getting results that work up to the hour. And when you do a select from this table, you get the immediate results, the freshness with the lag, and you get snapshot isolation. And this is what I was telling you about connecting all of these tables. Of course, we are processing a lot of data. We're doing a lot of transformations. We're doing joins, dynamic tables. You can say that my target lag, look at downstream, and whatever the final table has. For example, I want this report fresh daily. None of this will need to process until the 1 day mark. And I can control the whole lag in one place, which is cool. So what do we have with dynamic tables? Declarative data pipelines. They support SQL. They support joins, unions, aggregations, window functions, group by filters. You have the whole power of SQL here. We can look at any of the restrictions in a second if you want. You define the latency up to a minute, down to a minute. It's all automatic. And being consistent, having snapshot isolation is important. This is really cool on enterprise. CDC, like if you're streaming rows from any other database, this is a cool way to rebuild the database and rebuild the whole pipeline. This is good for AI and ML analytics. The ability, for example, to score things and to run a Python UDF that was used running a model beneath it, and to have everything simply taken care of by the database is pretty cool. It looks like batch, but it's streaming. When I talk to the engineers behind dynamic tables, like Tyler Akidao, and many others that came from the Apache Pinot project, some came from the Flink project, they joined Snowflake to deliver a vision of, yes, we love doing streaming, but we've been doing streaming outside the database. How does streaming look when we are doing everything in the same place? How do we simplify the whole process? We get rows, you get the tables that you want to see, and you get all the downstream changes replicated. So you get version control, you have documentation and testing. If you use dbt in the past, in the past and today, a lot of people use dbt to define their data transformations, and they run dbt once a day, they run dbt once an hour. What if instead of running dbt to run the transformations on a schedule, we just ask dbt to set up the whole pipeline of transformations, and from then on, Snowflake is taking care of those transformations as new rows come in. Yep, that brings data as a product. We define what we want. Snowflake makes it happen. We want the reports that we want. We get the reports that we want. We have some example architectures. These are from my field CTO friends that go to companies. They build different references for them. I will quickly show you what they gave me here. what I was telling you, Kafka files. This is for an enterprise security example. Financial services and insurance. Of course, we want to do replication of MySQL, Postgres, anything with CDC. I'm going to wait a second for the picture. IoT, perfect. Yes, I like how it's a very similar diagram, but suddenly it's from your industry, and it looks different. So that's why we work with different industries. We have field CTOs that are focused on each industry. Advanced personalization in retail, of course, Kafka, Kinesis, etc., and working with notebooks, Snowpipe, etc. Now, second, to go deeper into what's new, Snowpipe streaming, our ability to read from Kafka, is generally available now for a couple of months now. You can do OAuth authentication, that's new, better retry logic, network upload optimizations, observability, that's really important. How do we deal with errors? How do we deal with drop channels? Targeting the lag, and working with the schema detection and evolution. That's also really important. Then, this is very new, April 29th. Dynamic tables are now GA. That's also really cool. And I wanted to highlight some of the news here, sharing and collaboration, how the part of the beauty of having this inside Snowflake is that you get all of the benefits of your company data warehouse you might want from. So you're running Snowflake in multiple regions. Let's share this data. Let's share these dynamic tables of results, not only between the regions. That's more of the disaster recovery and replication part, being able to have this distributed and ready to take over when one cloud goes down. We have another. Snowflake is running in a different cloud and ready to keep the process going. Sharing collaboration is all about sharing with different teams, with sharing with different companies. If you are, for example, TripAdvisor and you are selling data to other people that are interested in TripAdvisor's data, you can be the Snowflake marketplace. You can define all of your processes with dynamic tables, and then your customers, your data customers, can get all of this. Observability is really nice. I want to show you in a second how these dynamic tables look inside the Snowflake. I only showed you at the setup part of the demo. I didn't show you how it looks inside the Snowflake, so I'm going to go there. Data cloud integrations, that's all of the Snowflake features, like doing clustering, having transient tables, governance. Governance is so important to have one easy and understandable way of govern and have data masking, row level security, column level security policies apply on the same process. That's really, really important. You get all of the scalability of Snowflake. Query evolution support is new. So if you do a select star and things don't change, the dynamic table will work. And we are doing a lot of documentation. So on observability, let me show you how things look on the Snowflake side. This is SnowSite, the typical, let me zoom in a little bit. This is a UI that most Snowflake customers use. You can also use VS Code or whatever your UI is. And then we are also adding native notebooks very soon. So let's go back to the demo and how I did this on the Snowflake side. I created a schema, I created tables. This is a pretty normal table with all my common words that I want to eliminate. Then this is my table with the AdWords. The word festival will trigger a win a trip to Coachella ad. And each ad has a weight, how much the customer is paying for this ad. Landing word stream. This is basically when we create a stream, our client, the Python app, is able to look if Snowflake dropped any new ads and just get the new words and new changes. And this is where we created the dynamic table with the word aggregation. So basically, I'm looking at my landing words. These are the words coming from Python. And I'm eliminating anything that's not from common words. Really simple select and negative join. And the cool thing is that I'm telling Snowflake, look, if there's any new data coming, look at it every minute. And if there's new data, then run this. Run this for the whole source table? No, run this only for the new data. Snowflake will take care of doing the merge. But I don't need to think about merge. I don't need to think about all of those syntaxes. I just need to tell Snowflake, this is what I want. You go and figure out how to run the process. And then for the add results, it's another join. Basically, I'm getting all of my words, counting from this table, and then I'm joining with the adds. And if anything scores and it has a big score, that's our output. And again, this will work every minute in an incremental fashion. And then things start working. I could be streaming these words in, but I could also be inserting them, and I get the results. Then the observability part is pretty cool, too, because you get to see, like, these are my dynamic tables. So I have my tables, which are the add words, common words, landing words. But my dynamic tables are the word aggregation and the add results. And this is how we show the awareness that Snowflake has of the whole process. It's looking at my two tables here. This is a dynamic table that has a target lag of 1 minute. I can look at the history of it. And then AdWords, it's also a normal table, but the dynamic table is doing the join, doing the target lag. We can see at the refresh history, are we working within the lag that we ask? Are things getting out of control? So maybe I gave it too little compute, so we would see a current lag that's, sorry, I wanted 1 minute lag, but things are taking 5 minutes. Maybe I need to give this more power, and that's what I control by assigning it a different warehouse. But yeah, I love being able to see how my Snowflake, as you can see here, not only knows about the tables, it also knows about the dependencies, what's our DAG of data, and how everything relates. If you want to see the data, we can see, like, yes, these are the words that I inserted, and it's all working together. We can go into the limitations of the dynamic tables, too, if you want to do that. But let me talk a little bit about the differences between streams and tasks and dynamic tables. With dynamic tables, everything happens magically. I can go deeper if you want, but as a quick Snowflake overview, the old way of doing this inside Snowflake was streams and tasks. And streams is our ability to give stored procedures a view of, oh, these are new rows that we just added to this table. What do you want to do with these rows? That was the old way of doing things. Dynamic tables are also similar to materialized views, but they have different kind of power. Materialized views are more limited on what you can do with a materialized view. And also, a materialized view doesn't have the target lag concept. A materialized view sees that there is new data in the table and automatically proceeds to compute everything. And that doesn't give us a lot of power to define how much we want to spend on refreshing things. It's way better if we are able to say, no, it's OK if there's new data in your source table. I don't need you to update until someone that depends on you needs that refresh. A materialized view can only see a single table. A dynamic table can look at a lot of tables. Dynamic tables have all the power to, again, do all these things. We support Python, as I was telling you. The key features we already looked at. And we looked at, this is how we work with the dynamic tables, that we can ask them to refresh. Like if we can set, like, for example, that the target lag is whenever. We don't care if that refresh or not. I just click ask it to refresh. It will refresh the whole DAG of connected tables with one request. You can suspend them, so you stop spending credits on those suspensions, and you can bring them back to life too. So yes, in this example, we have everything suspended, but we ask for a refresh, boom, the whole DAG will compute. Observability, I just showed you how cool it is for looking at the cost transparency and also for monitoring pipelines. And that's my talk. During the question time, we can go into the limitations, whatever you like to talk about. And I love feedback. Thank you for coming here. You can leave me feedback in that form, and I will tell my manager if you didn't like my talk. Yes. Thank you.
Any questions, guys?
Yes, we have one here. Nice T-shirt, by the way.
Oh, thank you. I got it here. I guess brand new. Yeah, is the source code for the Python code that does the voice to text available in a public repo, or is that something proprietary that you guys can't share?
How we did the voice to text? Yes, that was a cool part of the demo. And we have all of the Python code here. What we are importing is Whisper. And Whisper is a model that Python Whisper is a robust speech recognition language. So if you can record audio, you have a WAV file, you can run Whisper either in this demo, we're running it in my computer, or you can run Whisper inside Snowflake too. Yes. Thanks.
Any more questions?
Yes, please.
So now that you are GA with dynamic tables, do you anticipate the streams and tasks usage will go down, and this will kind of be the main way people will declare data pipelines?
So the question is, how is Snowflake going to deal with the streams and tasks versus dynamic tables?
Yeah.
We love having both options. Dynamic tables bring a lot of magic, while streams and tasks give you a lot of flexibility of what do you do with these new rows. So I feel people will be using both for a long time, depending on, do I want the magic process, or do I want to have exact control of, you know what, for example, a dynamic table always tries to do a merge, or it's always looking to see if by ID you updated any of the rows. And you might think that, you know what, I have a table that's increasingly incrementing. I never want to revisit all data. So you can simplify and make a faster pipeline in that way. Now, what dynamic tables are today, it's not their final form either. The engineers here are working on how do we define that type of restrictions of incremental refreshes, having giving it the ability to look only at the file last minutes of data and not care about updating the old data. Those are new concepts that are going to come in the future. For now, if you want to have more of that control, streams and tasks is the perfect solution. Thank you. You use Snowflake now?
I have looked at that page where you show the differences. I'm building a similar feature in Flink for materialized tables and views at Confluent. So we are looking at what you guys are building and seeing what the trends are.
Nice. So well, hopefully this was useful and will help you with the next steps of experimenting. Thanks. Any more questions?
So I have a question regarding does the dynamic table support like deleting data? So when you delete data, does it get refreshed automatically?
I missed the, I heard
So-
refresh, but
So for example, you have the base table, and if I'm deleting record from this base table, does the dynamic table downstream get refreshed automatically as well?
let me go back to the table to see if I...
Because I think it's intuitive to think about adding record, keep adding record, ingesting new record into the base table.
Sorry, the microphone is a little...
Oh, it doesn't work?
Yeah,
Oh,
but it's okay.
yeah.
I'm here too.
So basically, what if we delete what if we delete a record from the base table?
Oh,
So
it's
how
easy.
does it work for the
Yes,
downstream
how
dynamic
things
tables?
work within deletions. Good. So what happens if I delete a record here? The whole thing will refresh. Right now, so what happens with streams and tasks that we were discussing earlier? When you have a normal table like this, and you create a dynamic table, Snowflake has this previous concept that we still dynamic tables use, which is, OK, to this base table, we have a stream of changes. This stream of changes are either new rows, updated rows, or deleted rows. And when we were using streams and tasks, then I had the choice of what do I do with these three things. In the case of dynamic tables look at these rows, and they understand they need to reprocess anything that was reprocessed, and it runs a merge. So what's cool about dynamic tables is that they are very aware of any change that happened to the underlying tables. And this is cool. Like, if I have 10 terabytes of data and I have a dynamic table that was looking at those 10 terabytes, yes, the first run, it had to process a lot of data. And then I keep adding data. That's cool because the dynamic table will only look at the new data. But then the source table got one delete, important in the GDPR world. The dynamic table is aware that that change happened, and it will recompute the important parts.
I see.
So yes,
yeah.
Great question, especially when we care about deletions.
And thanks for that. And another follow-up is, so in the dynamic table, you have those aggregation function like a count or sum or min max. So one tricky thing which we also encountered recently is if you delete a record, how can you incrementally update the results for aggregation like min max or some other kind of aggregations? Because for sum or count is relatively easier, but there are some aggregation function is pretty challenging to update incrementally, particularly when you're deleting record. So how do you folks handle this?
Yes. So how do we work with the deletes when we are doing the aggregations? That was the hard part of delivering with dynamic tables. But this is not published code, but how I see it working. When you do a group by, you are grouping by certain fields. And everything else is a summary of it. Because I'm grouping by these fields, that becomes the key of the row. There's no other row that has the same set of keys. So the only thing you have to do at the end is like, oh, this grouping of these three keys changed, and now I have to update this row. And you can see it like when we have the refresh history. Ooh, my Mac is about to die, right about on time. You can see how many rows change. So I didn't run the demo right now, but you can see that, oh, and you can try the experiment. You have your 10 terabyte table, you have the groups, anything weird thing you want to do with SQL, and you will see that, yes, only the rows that I wanted changed. And I could run the experiment right now. Hopefully, my computer doesn't die. But let me insert something on landing words here. I inserted one word. this will update within 1 minute. Let's see what happens within 1 minute, but we can get one. Oh, yes, this is how I can show that everything is working as expected. And I can delete it too in a second. My data preview. Yes, it has changed. My ad results have not changed. Oh, because I'm looking at the wrong refresh history. Yeah, I had 2 tables, and yes, you can see here that as I added one keyword to the words table, the one that's doing the word aggregation, added 2 rows, deleted 2, the preview looks similar, but the count is. So yeah, if I have more data, if I have less data, things will change within the. And where is my data here? I have so many examples, FHDB, my schemas, my voice demo, my dynamic tables, which was the ad results, refresh history. Yeah, here you can see like changes are happening in the last minute, nothing happened in the previous minute. It basically changed 3 rows, but you have full visibility of what happened underneath. Thank you for letting me show this.